Hello viewers, in today's session we are going to discuss another important problem from differentiability of functions, and in this session we are going to discuss the derivability or differentiability of this function f of x, which is the product of x square and mod of x, right? And here this function is valid for all values of x belonging to the set of real numbers, right? And we have to test whether this function is differentiable at this point, that is x is equal to 0, right? So viewers, we have already discussed a lot of problems related to differentiability of functions, and here we'll find out the right hand derivative and the left hand derivative of this function f of x at x is equal to 0. And if the left hand derivative and the right hand derivative both exist and they are finite and equal to each other, then we can claim that this function is differentiable at this point, that is x is equal to 0, right? So let us first find the right hand derivative, and then we'll find out the left hand derivative. So let us first write this function f of x slightly in a simplified form, that is using the definition of mod function, because mod of x is defined like this. Mod of x is positive x whenever x is greater than 0, and mod of x is equal to 0 when x is equal to 0, and mod of x is negative x whenever x is less than 0, right? So here using this definition of mod x, we can now write f of x as x square times positive x whenever x is greater than 0, and f of x is equal to x square times 0 when x is equal to 0, and f of x is equal to x square times negative x whenever x is less than 0, right? So we can now rewrite this function as x square times x is x cube, that is x is greater than 0, and x square times 0 is 0 whenever x is equal to 0, and x square times negative x is negative x cube when x is less than 0. So now the form of the function is given by this expression, right? So here we'll use this form of the function in finding out the right hand derivative and the left hand derivative. So now the right hand derivative is defined by this limit, that is limit h tends to 0, and we have f of a plus h minus f of a divided by h, right? And the notation for the right hand derivative may be taken as f prime, and here we write a positive sign, and here we have a, right? So a is the point where we have to find out the right hand derivative. Now here our point is x is equal to 0, that is the uh, uh, value of x, that is x is 0, that is equal to a. So a is 0, so the right hand derivative is equal to f prime of 0, and here we have limit h tends to 0 f of 0 plus h minus f of 0 divided by h. So we can now write limit h tends to 0 f of h minus f of 0 divided by h. Now f of 0 can be obtained from here. When x is equal to 0, then f of 0 is equal to 0. So here we have 0. So we can now write limit h tends to 0 and f of h over h, because here we have f of h minus 0, that is simply f of h. So now let us find out the value of f of h. Now see, this h is infinitesimally very small, but h is a positive quantity, right? So h is a positive quantity. So when x is greater than 0, it means when x is a positive quantity, then f of x is defined as x cube. So we have limit h tends to 0, and for f of h we can write h cube over h, right? So here we cancel this h, so we have limit h tends to 0 and h square. So now this limit is equal to 0 square. By taking h is equal to 0, so we have 0, right? So the right hand derivative of this function at x is equal to 0 or a is equal to 0 is given by 0. Now let us find out the left hand derivative. Now the left hand derivative is defined by this limit, that is limit h tends to 0. We have f of a minus h. In this case we have a minus h minus f of a divided by negative of h, right? Now a is 0 because the given point is x is equal to 0. So here the notation for left hand derivative is f prime. Here we put a negative sign, and here we have a. So this is limit h tends to 0 f of 0 minus h, and then we have f of 0, and here we have minus h. So we have limit h tends to 0 and f of 0 minus h. So we have simply f of minus h, and f of 0 is 0. So we have f of minus h minus 0 is f of minus h divided by a negative of h, right? Now f of minus h can be obtained from this expression, that is when x is less than 0, because here h is a positive quantity, h is greater than 0, so negative h is less than 0, right? So we can now write limit h tends to 0, and f of minus h can be obtained by taking x is equal to minus h in this expression. So we have negative minus h, and here we have cube divided by minus h. So we have limit h tends to 0. Here negative and negative get cancelled. We have simply minus h cube over h, and here h get cancelled, and we have minus limit h tends to 0 h square, and if we take h is equal to 0, over here we have 0 square, that is equal to 0. So the left hand derivative of this function at x is equal to 0 is also equal to 0. So now from this discussion, we have seen that the right hand derivative is equal to 0 and the left hand derivative is also equal to 0, right? And moreover, right hand derivative and left hand derivative both exist, and they are finite, right? And they are also equal to each other, that is right hand derivative is equal to left hand derivative, right? So we can now claim that this function f of x, that is the product of x square and mod of x, is differentiable at x is equal to 0. It implies that the derivative of this function f of x, it exists at x is equal to 0, because the right hand derivative and the left hand derivative both exist, they are finite, and they are equal to each other, right? So viewers, this is how we can discuss the differentiability of functions of these types.